Hi, everybody. Thank you for coming. And how Devoxx is doing? Woo!
All right. Yeah.
It should be more caffeinated by now, but we'll try to wake them up a little bit.
Yeah.
All right. Yep.
Shall we start?
Yeah, we should just start. You know,
All
that's.
right. Yeah. So wow. Thanks for having me here. Actually, this is my first time ever in Ukraine and in Kyiv. So thanks again for having me here, and thanks again for being here in this session. My name is Ray. I'm a developer advocate for the Google Cloud Platform. What that means is I like to do two things. One is to bring some of our best technologies to developers all over the world, whether it's on Google Cloud or on the open source projects like Kubernetes and Istio and gRPC. I also like to make the developer experience better, especially for Java developers. I've been a Java developer myself for a very long time. For that reason, I started this project with the Google engineers. It's called Spring Cloud GCP. So if you're using Spring and Spring Boot and want to try Google Cloud, give this a try. Anyways, if you have any questions, you can find me on Twitter at Satanism. And of course, we also have...
Yeah, hi, and my name is Baruch. I'm developer advocate. That's very loud. I'm developer advocate with JFrog, probably doing my best to make your life easier with artifacts and stuff. We're going to talk a little bit about that today. And I'm a very entertaining guy. You should follow me on Twitter like immediately, right here. If you are not convinced yet, don't worry. You will have our Twitter handles on each and every slide. So whenever you decide to follow us, our Twitter handle will be there. Very convenient. Think about you.
Who hasn't followed you yet?
I don't know. We'll see. We'll see the delta, and we will know if someone didn't.
Okay.
Yeah.
All right. It's awesome. So definitely follow. Okay.
And very important slide. The only slide that you need to take a picture of is a special page called Show Notes that we've created on JFrog. What's going on?
Oh, there we go.
Here you go.
Animation.
JFrog.com/show notes. The slides are already there. The video will be there soonish. I hope by tomorrow we'll see how we will manage. All the links, that's very important. Whatever technologies and tools we are going to speak about, they're all there. So you don't need to Google them or take pictures of the whatever it is. It's all there. Feedback to tell us how awesome we are or not. And a small present for being here, a little raffle of something nice is there for you as well. So jfrog.com/show notes, that's the only slide you need to take picture of. If you forget now, on the bottom of every slide you have this URL as well, so you can always go and write it. All right.
Cool. So today we're going to show you something with microservices. How many people here are developing with the microservices architecture today? Well, just about everyone.
Wow. Everyone.
Okay,
yeah.
Very cool.
And part of them really doing that, and part of them are just liars, but we don't really care.
No, I don't know. Maybe, but hey, here's what we got. So this is one of the best applications I can ever write, to be honest. It's the best looking application.
It's beautiful. It's beautiful.
Yeah,
CSS and stuff. Look at the black header in the top. I mean, this is beautiful.
Yeah, it's just a black background. And oh, by the way, did you know this is using Bootstrap and jQuery, actually?
Obviously.
Yeah,
what can you write without
exactly.
jQuery?
Yeah, and it's got two of the best applications I can ever write, which is a guest book, which you can say hello to, and something that says hello back to you.
Like an echo server.
Yeah, well, like a guest book, like the old guest book CGI application.
Amazing.
Yeah, except that this is all done with the microservices architecture. Just to demonstrate some points, so we broke it down into different services. Of course, we have the front end, the UI, the back end, and how's the database.
So you have like 3 microservices for 2 lines of application, basically. Good job.
10 lines. 10 lines. Yeah. A little bit more than 2.
Yeah.
But also this is made so that they can be scaled out.
Oh, we need to, right? It will become so popular. People want to say hi to you, and you need to stand the load. Obviously, it should scale.
Exactly. It's gonna be wildly popular in just a few minutes when we show it.
Yeah, absolutely.
Yeah.
Yes.
So let's take a look at it.
Oh, live demo. Look at that. Look at the Ray.
We go straight into live demo. All right. So what we have here is we deployed the microservices in Kubernetes. In Kubernetes, what we can do is to write these deployment descriptors, these YAML files, which we can describe exactly what we want to deploy.
Oh, this is so good. This is like YAML. Who loves YAML?
Yes, everyone.
What?
Who wants JSON? Oh, see, YAML wings. Who wants XML?
People,
there is.
what's wrong
Always
with
a
you?
few, yeah. There's pros and cons for each, right?
Yeah.
But
Lua, anyone? No.
Yeah. All right, so this is YAML. What's that?
Property files.
Yeah, there we go.
Oh, we should hack a application that
Yeah.
you can write Kubernetes deployments in Java property files.
Oh, that's. But you know, in Spring you can also use YAML files now.
Yeah, no, but
Yeah.
properties files are.
Yeah, but maybe that would be a good idea. We should
Alright,
give it a
yeah,
try.
yeah.
That's a $1 million idea right there. All right, so, but fortunately for this one, this is YAML. And the way that we have written it is, of course, you can say, hey, Kubernetes, how many instances of the container do I want?
At least
two of
two,
them.
that's
At least
HA,
two.
HA.
Yeah, HA, exactly. And then you can tell it which container you want to run, and you can give it the labels. These are important. These are key value pairs, which you can just name it whatever you want. You can give it a key and value, and this is gonna be important in a second.
Yep.
And then we have this invar and stuff like that, and health check, so you can check whether the application is up and running. So I already deployed everything here, so we can go get pods, and I think everything up and running right now. If I have internet, obviously, and there it is.
Here we go. Amazing.
Yeah.
So all that you need to run this guestbook, echo, 2 lines of code stuff.
Yeah.
That's all you need, basically.
Yeah, that's
Hello world.
exactly. Yeah.
Hello world.
Wildly popular in a second.
Yeah.
Yeah. So I also have this really nice visualization tool, which you can see.
This is beautiful.
Yeah, exactly. So we can see the number of nodes that we have. We have the front end, the back end. We can see who's talking to what. And also we have these load balancers that we set up.
Yeah, and this is all like live, and
Yeah.
if you take one pod down, it will reflect it here.
Yes, if you take one down, it will be reflected, and you'll see it come back up, actually. Yeah.
So, and this is like, it's a real topology of what's going on.
Almost. Yeah, almost.
What do you mean?
Well, I can tell you it is not Visio. Yeah.
It is not Visio,
No,
because this is
no.
what it looks like.
But check this out. So for example, if I go and delete a pod here, if we have the internet proper.
Yeah, deleted, all right.
Yeah, there we go. So
Here we go. It is live. It's not
It's
Visio.
live. Yeah, exactly.
Very nice,
Yeah.
very nice.
And we also have set up the load balancer here, so we can go to the UI service. And here we can see that this is a external load balancer. That's why we have an external IP address.
Okay,
Depends on which cloud you're on. You get a real IP, and so on and so forth. And we know how to route the traffic to the application based on the labels. So why don't we go take a quick look?
Yeah, let's just play with it. I mean, it's live. It should work.
Yeah. So I'm going to click on that link, and oh, nice. So you can see that this little Spring icon. This is a Spring Boot
that's
application.
Spring Boot application,
Yeah,
obviously.
very nice. So let's go take a look.
Huh?
Wait, hold on a sec.
What happened?
I don't know.
You have the link. Here we go. Yeah.
How do you do the hard refresh?
Command Shift R something. Yeah. Here we go. Okay. Oh, wait a second. So let's see. Internal server status 500, and then it's 404, and it's null.
Yes, one of the.
Wait a second. You mentioned it's all Java.
Yes.
So it's null pointer exception.
That explains everything. Yeah.
That's Java.
Yeah, but this is one of the worst exception that we've seen, right? I don't know.
You know what?
Do you have a backup or something?
I heard you have a very good record in showing demos and conferences.
Yes.
You wanna show us some highlights?
So I think I fail a demo every year at Devoxx Belgium. So for example, in 2016, I had a demo fail. 14 minutes into the talk. In 2016, I had a demo fail. 1 hour and 50 minutes into the talk.
That's a record.
I survived.
You went 2 hours without a demo fail.
2017, I also failed 31 minutes into the talk. And
this is now? Wow,
Yeah.
2 hours, 20 minutes.
2018, yeah, it was a university session. Yeah,
that's
why.
yeah.
It failed 2 minutes before the session ended.
But still, you managed.
Yeah.
So, Ray, with such an exceptional rate of failure demos, you probably have backup, right? You have a video that we can show or something.
No, I thought you were making the video.
Why? My demos always work.
No, but I thought you still were supposed to make the video last night. No?
So you don't have the video.
No, I don't have the video. No.
I think we're done here pretty much.
We're like only 10 minutes. Yeah, I guess. Yeah.
I mean,
well, yes. Let me try that. No. Well, Sorry, everyone. I guess, is it lunchtime? Yeah, is that what it is?
Soon, yeah, it will be
Yeah.
lunch after our session. We're 10 minutes into the demo. Should we let them go or should we try to debug the thing?
Oh, let's try to take a
Let's
look.
let's
Yeah,
try to fix it.
yeah.
Let's try to fix it.
Okay, so obviously the error message wasn't very helpful, was it?
Yeah, but no explicit mapping for error, so
Yeah.
you're seeing this as a fallback. Thank you.
Right, yeah.
And then there is unexpected error, which isn't
Yeah,
very useful.
It's the first time I've seen both 500 and 404 in a
And
single
null.
page.
Okay,
Yeah.
so I do have a
Anyways,
question.
yes.
Since you have such a stellar experience with demos, did you even tested it on staging environment on something?
Of course, yes, yeah, of course. You will never go to production without going through staging first, right?
That makes perfect sense.
Yeah,
So we have staging.
Yeah, so in Kubernetes, what we have is the concept of namespaces.
Namespaces.
So in a single cluster, what we have done is to carve it up into different namespaces, and we deploy exactly the same app into the different namespaces. And we created the dev namespace, the QA one, the staging. Typically, you put them onto a separate cluster so that they are not on the same production cluster. But for this one, we actually have the staging on the same cluster. So my production is running in default. That's what we're seeing.
3 years, good
Yeah.
runtime.
Yeah. Yes, it shows how long my Kubernetes cluster has been on Google Cloud. On Google Cloud
That's
platform.
solid. That's an achievement.
That's right there. Yeah, exactly. And we have the staging here, which you can take a look. So we can go and get pods and namespace staging. We have deployed exactly the same YAML file. Oh,
What happened?
well, I guess my staging didn't work either. Yeah. Well, what happened?
That explains it. So let's fix the staging. So we
Yes.
will prove that you actually had a staging when you deployed to production, to failed production.
Yeah, so so this is a pretty horrible sequence of events so far, hasn't it? So let's take a look at why this staging environment didn't work. So if we go into get pods and get staging, which could happen, right? It could happen to your application too, where your application just didn't come up. What we can do is do a quick describe here to see what happened here.
Yeah, let's do that.
So we can describe a pod, and we need to go into the namespace called staging. We should probably fix it first, right? Like, yeah, that's pretty
Yeah, we need to
important.
fix the staging to show you that staging is working, but production is not.
Yeah.
That was the whole idea.
Oh, there we go. We need to describe pod. There we go. If I can only type properly. as well.
That also might contribute.
Oh, there we go. Okay, so it's saying that I actually couldn't pull this image from your repository.
You couldn't pull this image. Okay.
Yeah, but I think that's probably because we
You are
needed
not
to,
logged in or something.
We needed to get my credential.
Exactly.
to the thing,
Login
right?
might help.
Yeah, so let me see here. Maybe I can find the secrets here. So in Kubernetes, we can store some credentials in secrets. In this case, I have the credential to your Artifactory in my secret. So I can do get my secret, YAML. Why don't I just get it from the production environment here? So I'm going to say secret.
So
.yaml.
now you assume that your secrets in the failing production environment can help your failing staging environment.
Well, I think that, well, in production environment, the application actually is running.
Yes,
So-
it's just failing, and
Yeah,
and
yeah.
in staging it won't even run.
Yeah, so
Okay.
let's give it a try. So I'm gonna apply this thing and with the -f, and hopefully once we created the secret. Oh, hold on a second. Ooh, we're gonna show your secret on screen. Is that okay?
Yeah, what can go wrong?
Well, a lot. They're gonna be taking photos.
Of course they will.
Well, no photo taking. This is what I'm gonna do. There we go. So,
Oh, okay.
whoa,
So you
there-
took it up, and now people won't see it.
Yeah.
This is smart.
Yeah, there we go. Let me get rid of that.
Don't look at the top of the screen, please.
Yeah, there we go. Let me just get rid of a few things. Whoa, yeah. It's gonna show up on your.
It was
YouTube
very
video.
fast. You didn't
Yeah.
have any chance. It is recorded, but well.
Yeah,
That,
we'll cut it out. Yeah, okay. So let's see if staging is actually working. Hopefully. So there we go. Arrow pull image. And let me just do something very quickly. I'm gonna delete all the pods here. Delete pods from staging. Let me just try one of them and just make sure that the thing is actually working. So let's see. And if it actually works, then we know secret was definitely an issue. Or we should have seen it when you do a describe. You should have seen it in the events. That's probably one of the first places I would go to if one of the pods didn't start, right?
so what I want to say is you didn't really try that staging.
Well, who does?
Fair point. Fair point.
Yeah. So let me. Why don't I delete all the pods here? So I'm gonna say delete. Oh, look, like this is up and running. So
yeah, we have one running. That's
yeah,
amazing.
let's make sure the service is back up, and also let's at least make sure one of each is back up so that at least we can show staging environment. Let's see. Well, that was close. I think that should be okay. There are a few that's not working yet, but I think that should be fine. That is because Kubernetes should be load balancing the traffic for you.
Yeah.
So if the pod is not healthy, because we have the health check and everything, the load balancer will only route the traffic to the ones that's healthy.
So
right?
that's HA. We have half of the pod still dead, but we don't care because we have another half which is running.
Yep, and we're just waiting for one more service to start up, and I think that's fine. And maybe we can hopefully at least see this application working.
That would be
right?
nice. That would be nice.
Exactly. We should have had that video. Anyways, so this is the...
That's the production.
Yeah, so that's the production one.
And it doesn't work.
No. And then you can clearly see the namespace, the staging namespace, and the IP address for the other one.
Yeah, that's the right address. It just doesn't work.
So let's see if staging works. So let me go to staging and moment of truth.
Oh, here you go.
Whew.
Here you go.
Well,
Staging works.
That was close. Well, it only works if I say hello. So I'm going to say hello and say greeting. And OK, that works.
Guys, the IP, you can...
Yeah, well... If you want to try it, please say something nice.
Yeah, and you can use the production as well. Don't. It's okay that it's down, but you can still go.
Yeah, you can try it. So that's really interesting. So using kubectl, I was able to find the events. I was able to fix my staging environment. Yeah, there you go. But our staging is still not working.
Yeah, the production doesn't work.
Production, yeah.
Okay, so let's try and debug it.
Well, we need to figure out like what is actually running in there, right?
Yeah, first question will be what images did you create your containers from?
Right.
That will be a good start.
Yeah, so let's go back and see our YAML file, which we can clearly see which image we deployed to make sure that they're actually the ones that we want to run. So here we can clearly see we wanted 2 replicas, but if we scroll down a little bit, we should be able to see the image we're going to run. And this is actually, hey, Brooke, it's in your Artifactory.
Of course it's in Artifactory, obviously.
And it's running Hello UI.
Great. Which version?
Latest.
Latest.
Of course.
Latest from when?
Latest from the latest. It's continuous delivery, continuous integration, CI/CD. So I'm always delivering the latest to my production environment, right?
So you have no idea which version is it?
Well, what do you mean? It's the latest one.
Yeah. Which one is, you don't know which one is it?
The latest one. What,
Kids, don't use latest.
Why? What's the
No, it's all good. It's all good. You want to go in Artifactory and see what the latest is?
Yeah, but we can
just
also...
go. No,
yeah,
I mean, just go.
All right, so let's see here. So how do we find out?
Yeah, just go and search for latest. Go, you can go to here, to the...
Okay.
To this one.
Oh.
And see, search for... what do we have? Hello World, yeah.
Would that be okay?
It's Docker.
I think you have an issue with Artifactory too.
No,
this is just a
use the wildcard.
this demo is not working in many respects, is it? Let me do a refresh because I could be logged out.
No, that's okay. That's okay.
No.
You just need more of the wildcards.
Why don't I just do like wildcard?
No,
you found
that
it.
will be all the images. Here you go. Which one is that?
The UI one. I think we need to take a look at it.
This is latest. Are you sure that's the one we're running?
I guess we need to double check.
Yeah,
right. So
exactly.
how
That's
do you
my
know
point.
which latest this is and what?
You don't know which one is latest. That's the idea.
Yeah, but
you do know a digest.
The digest.
Can we compare the digest?
I think we can.
Let's do that.
So is that the digest right here? Can people see it down here? Let me see here. It's 03478. Actually, we're going to do a checksum. Somebody remember the first 4 digits, and some people remember the last 4, and the things in the middle doesn't matter.
That's how it always works.
Okay, so you got it?
It's a hash. It's a hash. Hash of a hash code.
Yeah. Okay. So 0347892. You got it?
Yeah. I got it.
So one of the easiest way to kind of figure this out is to again use describe. So what we can do is to describe pod. It's very, very important to actually understand what is actually running in your environment because, like Baruch said, latest tag is very dangerous. You should never pull something that's latest or something that's actually mutable, right? The reason being that if you pull the latest tag today versus if Baruch pulled it from a week ago,
it will be a different latest.
Will be different from mine, right?
Yep.
And that's why this is not the best practice.
That's okay. That's okay. We have the digest. We have the SHA-2. Okay.
Yeah, there we go. So I remember the first 4, 0, 3, 4, 7. Yeah.
I don't remember. Let's just search for it and find it.
You don't remember.
I mean, let's just copy paste it.
All right, all right. So how do we do that?
Yeah. So now you go to search, have a checksum search, and you can actually find it.
Okay.
Okay. So what do we have? All right. So this is the latest.
Yeah.
The second line.
Yeah.
But now we also know that this latest actually have a version. That's version number 50.
Okay.
So now we are in battle stage.
Yeah.
Now let's dig into it.
Okay.
And see what else do we know.
Yeah, of course.
Yep. Okay, so we can go here to the 50 itself, to the Docker image itself, and see the Docker info.
Okay.
And look at that. Now we have all the images here, all the layers, and we can see what's going on. What's the entry point?
The app.
What do we have?
Yeah.
Java stuff?
Yeah, Java
all right.
stuff. Yeah.
The copy one below it. Did we just copy the file? This is our application file. This is jar. This is where the problem is. You remember what we need to do? Search by checksum. Let's do that.
What do you mean? Like
Let's search for that by checksum. Yeah.
This one right here?
Yeah, and we will find the application file that is the root of the problem.
Really? Okay.
How cool is that?
Assuming the app is bad, right? So why don't we go to the checksum here without the file, right? Do a search.
We didn't find anything. You know why?
Why?
Because the checksum is the checksum of the layer and not of the file.
Okay.
But that's okay. Let's go back and see what else we can do.
Okay, so let me go back to
Let's go to the manifest. Let's open it now and go to the manifest. You see these builds here in two lines? Right here.
Now, before we go there, hold on a second. Though.
Okay.
What is deployed by? Who deployed this thing?
It's Mark.
You're not Mark.
I'm not Mark. Are you Mark?
Neither am I.
Any Mark?
Who broke our demo? No, just kidding. All right. So, that's probably not the issue here. But let's see. We have the pipeline.
This is good. This is how it was built.
Okay.
Look at that. We have that's the link to our Jenkins.
Yeah.
If we go there, we can see the logs. We can see the sources.
Yeah.
Jenkins knows everything, right?
Yep.
Let's go to Jenkins.
Can we go to the pipeline?
Yep. Let's go there.
What's going on here?
Well, it's opening. It's Jenkins. It takes,
What if it doesn't? What if it never opens up?
What do you mean? Why?
Well,
what does it do now?
I don't know. It's not.
Did you kill the Jenkins?
I didn't do anything. It's not my fault. I haven't. This demo was working last night.
Did Mark kill Jenkins?
I don't know I don't know who that is.
So we don't have Jenkins.
No, but I guess Jenkins pipeline almost.
Okay, we don't have Jenkins. Let's see what else can we get from the build now. Let's go to the build.
Okay, so like build 50, yeah.
Okay. Here you go. Not bad, not bad. Look at that.
Yeah.
We have all the modules.
Yeah.
Snapshot, it's obviously Java. And Snapshot is almost as good as latest in terms of you have no idea what version it is.
It's CI/CD. You always deploy the last one.
Yeah, so at least you are consistent. If you use latest, you use Snapshot and the other way around.
Exactly.
Very good.
Okay.
All right.
Well,
okay.
I don't know, but maybe staging was running a different version. Maybe we should check that as well.
That's a good idea.
Yeah. So let's take a look at staging, and you can do exactly the same thing by checking the SHA-SUM, right? Because again, we're using latest tag. It's possible that they actually physically pull in different images here. So we can also do a describe on the pod, on the staging environment. Let's just make sure they are exactly the same thing, right? Because obviously this is not working, and that is fine.
Oh, people right here.
Yeah, okay.
Come on, people. Not nice.
I have no idea what that means.
Not good, no.
Okay, yeah. So here's 03478, and yeah, everything's the same.
Okay, so we have the same. What else can we learn from our build? I guess.
Gone. Yeah. Anyways.
Okay.
Yeah. So I don't know. What else can you learn from the build?
So we have it right here. That's already been opened and everything.
Yeah.
Okay. So you want to see how it compares to a previous build, maybe?
Okay. Yeah.
Just go up, and then there is like a comparison tab here.
Okay. Diff.
Yep.
Okay.
Let's compare it with the previous build.
Let's see here. It would be, I guess, that one.
Yeah.
Okay. From your pipeline, obviously. Wow.
Okay, so bunch of new artifacts. That makes sense. We created new artifacts.
Yeah.
Maybe new dependencies.
How do we know?
Let's go down.
Yeah.
Let's go down.
Go down. Go down.
That's all artifacts.
Yeah.
Here.
Yeah.
Dependencies? No. Everything is unchanged.
Yeah.
We didn't introduce new dependencies. No, we didn't break anything.
And I think at this very moment, I think we're pretty sure that the application is exactly the same as what we expected to be running in production.
And it actually runs correctly. It's staging, so it's a matter of state.
Maybe, yeah. So we need to go troubleshoot this a little bit more. Now, what happens if you can't get the right error message from your application right off the bat? You check the logs.
That's a good idea.
Yeah, let's
so
go.
now let's really get to business of investigating our running application.
Yeah. So we made sure that it's exactly the same app. We made sure this is the app that we're supposed to run. But let's make sure that to figure out how do we see the logs.
Let's check the logs.
Yeah. Now, typically, in a traditional environment, you have to SSH into the machine. I've done this myself many times, right? And you don't know which machine to go into, then you SSH into all of them, and then you do SCP, you copy all the files out, you combine everything together, and you try to figure out, get some information.
Anyone does it?
Yeah,
yes,
there you go, right? Or some people telnet into the machines as well.
And then you get into the container itself. Easy stuff.
Yeah. So in Kubernetes, what we do, of course, we can do kubectl logs with the -f. Then we can just give it any of the running instance, any of the pod. Then we can see the logs directly from it. Well, one of the things that you do need to do is to output the log to Std Out. That is very important. Try not to write any logs into the file system because that can actually blow up your container file system potentially if you're not careful.
And you need to log in to SSH into your Docker images to see that.
Exactly. So always output it to Std Out or Std Arrow. Now, Baruch, I have a question for you. We do have 2 instances running, just like the one that we SSH into.
Right.
We're trying to see the logs here, and we have 2 instances.
Yep.
What are the odds for me to find this error message in one of the
Obviously, 50%. You have
1
2
in 2.
instances.
But you know, in a microservices deployment, of course, you may not always have only 1 instance or 2 instances running. You could have auto scaling and stuff like that. So what if I scale this out to maybe 10 instances?
Yeah, that's good.
So I scale this out to 10, and when they all start, we will have 10 instances up and running. Now, Baruch, what are the odds for me to find this error message in one of these 10 instances?
50%. You either find it or not.
I don't know how that works, but okay, fair enough. My math is not very good, but I'll trust you. Yeah. so let's see. Let's take a quick look. I do have the logs here. I'm gonna do a logs f, so I can tell the log, and maybe I go into one of these instances.
What are the chances? 50%.
Oh, there we go. Wow.
Oh, wow, that was a good. I mean, you hit directly the one that has all the has all the exceptions.
I should obviously go buy some
lottery tickets.
Yeah, exactly. So we can see here the exact same message here. Oh, so we know a little bit more, right? We see the logs.
Here we go.
There's a 404 null and stuff like that. But of course, you know, if you do have many instances running, you can't really just go into every single one of these instances one by one. And there are some tools on the command line that can help you. One of them is called Stern. The other one is called Kale. Both of them can do this, which is that you can just give it the name of the deployment that you want to get the logs from, and then you just give it a name. And what it's going to do is to find all the running instances for that particular deployment.
And gather the logs together.
And you see all the logs together.
Yeah. And they are in colorful as well.
Yeah, exactly. So you can see the colors. They are color-coded to the different environments. And whenever something happens, you can see the logs. However, if this is a real production environment.
And it is.
Of course. What you're going to see is something like that.
That's like Matrix.
Yeah, that's like a matrix. Like
and we can read all of it. Down. Yeah, that's cool stuff.
I can see the mountains. I can see everything there in my vacation when the outage is happening. So that is not very cool. Useful. Yeah, but right. So this is a really nice troubleshooting tool if you are in a non-production environment, or maybe your production doesn't, produce a very verbose logs, then maybe you can see it.
But it's not our case. Our production is super successful and busy and everything.
Super busy. In which case, in most of the Kubernetes installation, what you end up doing and what you should do as one of the best practices, of course, is to install some kind of centralized logger. And for that, you can use like the Elk stack, the Elasticsearch, with the Kibana and Logstash and all that.
There are tons of them. There is log entries, and there is Sumo Logic, and there is Splunk, and there is so many.
Exactly. And what they all should be able to do is to capture those Std Out strings, or however that Kubernetes is storing these logs, and capture them and stream them into a centralized logger.
And then you will have a query to search in it and everything else.
Exactly. And we so happen to be running this on Google Cloud Platform. And so what we can do is to go into all of the cluster that we create here have centralized logging installed by default.
Out of the box, which is very nice.
Right. So you can, of course, use open source tooling if you want to. But here we also have something that's pre-installed by default. And what we can do is go into what we call Saturate Logging. And let's do some searching here. So we can go into the cluster. We can go into the namespace that we want to see. We can also see the container that we want to look at. Right. This is one of the things that you can do.
And
we can
let's
see
search
the
for
arrows,
500.
Or we can search for exception.
Exception.
Yeah, let's do that. And we can obviously see the exception here. And we can see a lot of these more information in more detail. However, it doesn't really help me if the exception is occurring all the time, because at this very moment, this is still not fixed. One of the things I usually do in a production outage at 2 a.m. in the morning, I really want to find more info.
Yep.
Particularly, I need to figure out, and I've done this before in my previous jobs, I need to figure out if the issue is only limited to one machine, or is it everywhere.
Do we have like a bad pod that we can always kill and get a new one?
Yeah.
Or you have a systematic error that
Right.
you actually need to take care of?
Exactly.
Can we see in which pods this exception actually occurs?
Yeah, we can. But because if it is happening systematically across the board, then I know I have a very long evening ahead of me, right?
Oh, yeah. Oh,
So
yeah.
let's take a look. What we can do here, and typically in a centralized logger, you could actually export the log, or you can do a search of the log, and you can query the logs. In this particular scenario, what we can do is to export the log into different sinks. So we can do almost a real-time analysis with the messaging system, with PubSub, or my favorite, which I've used before, which is BigQuery.
Oh, how convenient. It's a Google tool and it's right there.
Yeah, and what we do is this is a tool that's built on top of what we use internally called Dremel. This is one of the things that can query structured data, like terabytes and terabytes of them, without actually having indices. So we actually can use it to query logs, and that's what I've done in the past when I was working on a different team to figure out like real issues. So I have a query here set up. So we do want to go and figure out, can we get more information from the log, right? So let me open the pre-written query here. This is what we can do. Here,
cheater, I wanted you to write it from scratch.
Yeah, that might take a little more time, right? So for example, here, I can, oh, what happened here? Oh,
Wi-Fi?
2018, yeah, maybe. What is the date today? 11/23, 11/23 maybe, right? So what we can do here is to write a regular SQL query. We can query against a table like from today. We can also make sure that we're only searching for containers.
That's
we're
what we
looking
need.
for exception in the text. We can do regular expression too, but we're
And
also gonna do
this
grouping and
is the
ordering.
most important part, the group by.
Yeah, we can group by the name of the pod, and then we're gonna sort it by the occurrences of exceptions. Maybe there's one instance that is just particularly bad.
This is very cool.
Yeah. Okay, so we found one. There it is.
I
That's
mean-
the one that has the most issues.
Well, the rest have some as well, but this is Java. I mean, 35 exceptions is like, it's fine. It's like no exceptions at all.
What, per day or per hour? What?
It's 35 exceptions. I mean, you start up Tomcat, you get 35 exceptions.
But that's ODC exceptions. I can't see my app. Yeah.
Did we get now more than 57?
It will eventually catch up. Yep, the log are synchronized automatically.
Not yet. All right.
Yeah, so
okay,
some
okay.
of them got more right there. Yeah.
Yeah, so this is the problematic one, the 37.
That one. Okay, so
This is where the number of exceptions grows.
yeah, exactly.
This is how you do it, right? You remember the number, and then you get more exceptions,
Yeah.
and then you can see which one actually had more now.
Yeah, maybe. Yeah, exactly. But this is not a real-time analysis. If you want near real-time, you need to use the messaging system for that.
All right.
Yeah. So I don't know, Baruch. Like this one seems to be having the most issue.
Let's just kill it.
No.
How about that?
No.
Why
no.
not?
Well, I know it's a Java application.
That's another reason.
What? Like setting up a cron job and kill it every week?
And the important part here is to run this cron job in PHP, so it won't be in Java, because then you will need to kill the cron as well.
So how many people here used to do this, where your JVM runs out of memory every week, and so you actually do have a cron job that kills your JVM?
That restarts
every
your
week.
machine every week. Yeah,
Yeah.
there are a couple
There's always somebody in the room. Yeah.
Yeah.
There's always somebody here. Maybe I've done it myself too. Just so you know.
I'll tell you what, those are the brave ones.
Yeah. Yes.
We have at least 10 times more people who are ashamed to admit it.
And just so you know, if you want to do this continuously, Kubernetes does have cron job built in. But you're not supposed to do it just saying that's not the best practice. Don't quote me on it. Do not tweet it. Don't do it. Because if you kill the pod, what happens then is you lose all the information. You don't know why the issue is still happening. Right?
Okay. So you want, instead of killing it, you want to interrogate it.
Somehow, yeah, I need to ask questions. I need to figure out why.
This is cool.
Yeah. So the issue here is that if you just remove it, sure that you don't have the issue today anymore, but a week later it happens again, and you don't know the reason, and you killed it again, right? That's what happened with the cron jobs. What we need to do is to somehow isolate the process so that we can dig in and figure out more.
All right. Okay. So let's interrogate it first and then kill it.
Well, maybe. But, so this is what we can do. So we can get a list of pods. Now remember what we use with the labels, right? So what we have done is that we can see a label. I set out a label called serving. So
and this is not like a built-in concept like a keyword or something, this serving thing.
Yeah, it's something that I created myself. So
it's just a string. It can be anything.
Exactly.
All
so
right.
here I have the label called serving. So in my deployment, I have the label called serving. I set it to true. And then in my load balancer, this is a really, really important part. Remember how the load balancer can route the traffic. Right, so this load balancer is routing traffic to not just the hello world UI, but also any of the pods with serving equal to
Only
true.
those which serving set to true. So
Exactly.
all we need to do is take this misbehaving pod, set it serving like to false.
Exactly.
And then we kind of isolated it. It's out of service.
Yep.
People won't hit it anymore, but it will still be live, so we will be able to debug it.
Exactly.
All right.
So here what we can do is to change the label live in the running system. So what we can do is to kubectl label. We can label this pod, and then we can overwrite the serving label to false, for example.
Serving false.
Yep.
This is great.
So as soon as I do that, I would have taken this out of service, and we can clearly see that this the instance is now false.
Right.
However,
we should see a new one, because
Yes.
we asked for 10. If we decommission one of them, we should see another one coming up.
That's exactly right. And Kubernetes will always try to have the number of instances that you want. And right now, we see that there's a new instance up and running to take over the instance.
So we
that's been
still
taken out
have
of
10
service.
pods in service because our guest book is so low that we need at least 10
Exactly.
instances to serve it. Yep.
Yep. So now this is out of service. So theoretically, if that was the issue, if I go back to here, it should still be working, but obviously it's not. So let's figure out if we can get more info from this pod.
Yeah,
right?
yeah.
So what we can do now, of course, now it's isolated. It's not serving any traffic. Of course, we can go in here. We can go exec into the pod. We can run whatever things that we want. We can attach a debugger if you want to.
Oh,
We can
yeah,
do
that's a good
PX.
idea. Let's attach the debugger.
Yeah, we can do a PS here. We can see everything. We can, no, not that one. We can do JStat. We can do a thread dump with a kill-3, right? So we can see a lot more info without having this to be serving the application. Now, if you actually want to attach to like a GM export, if you want to test this particular instance out, what you can do is to do a pull forward into the pod directly. And the pod is on port 8080. I'm going to bind it to 8080 here as well. I'm going to maybe kill one of these other things so I don't have port conflicts. So what this will do is that without having you to SSH into the machine, it actually creates a tunnel directly into that container. So it doesn't matter which machine this is running on. It will go through the master node, will establish a secure tunnel here, and then go straight into the pod.
So now we can do stuff like take IntelliJ IDEA and connect the debugger, and you connect it to the port of the cluster,
Yep.
and it will actually connect to this particular instance.
Exactly.
And
so
we can use localhost.
8080.
Woo!
All right. Oh, so there's a lot more. Yeah.
It works. Look at that.
Okay, so this instance obviously works, and production environment is kind of working for some people, I guess. So I mean, there's nothing wrong with this instance.
No, it's not. It's not.
So I guess we can either remove it now because we're done with our debugging, or if we really want to, we can try to put it back into the whole
Because
service.
it has some state that we want to preserve.
Maybe, yeah. So to do that, we can just go ahead and rewrite the label, so we can put the label back to true. Now remember, Kubernetes. We asked Kubernetes to only run 10 instances.
So now we have 11.
Now we will have 11 in total. So Kubernetes at this very moment would have to remove one of the
It's
instances.
terminating. Which one will it kill?
So there's some heuristic behind how Kubernetes decide on what to remove. So first of all, it will remove the instances that's not healthy.
Yes, that we already did.
right? And then it will remove the ones that might be having the shortest runtime.
So we will kill the youngest, the baby.
The baby processes.
The baby pods.
The processes.
They are so nice. And we'll take the youngest baby and we will terminate it.
No, well, it's because potentially that the longer serving ones are the most healthy because it has most of state.
They have wisdom, they have experience.
Yeah, exactly.
Why would we kill them? Let's kill the babies instead.
Well,
Good thinking, Gray. Good
processes.
Yes.
Yep. All right. So we put this thing back into service.
But we wanted to debug it. How can we debug it now if it's in production? If we connect now with Debugger to it, it will solve the problem.
It would, but we because it is a complicated system, right?
Yeah.
And I remember this view that we had before we.
Here we go. There are 10 now.
Right?
Yeah.
Yeah. So this is live. It's not.
Yeah,
Visio,
it is.
right?
It's not a Visio.
No. So what do we see here? It is a complicated system.
It is.
Right. So the issue could have happened anytime along the way.
Yes, absolutely.
So we need to figure out, like who is actually talking to what, and we need to, based on some kind of view, some kind of documentation.
You have all the view right here. You have all the arrows.
Yeah, so here we can clearly see Hello World is talking to Guestbook service, so maybe that's the issue.
Amazing.
And maybe it's talking to Hello World service.
But you don't really know to which one of them, do you?
No. And also, a little secret. This view, although it looks nice, this is actually documentation.
What do you mean?
So the reason why these little lines are being drawn for me to understand this entire tree is because I hard-coded it. And I did it here in the annotation. So somewhere along the way, my visualization tool is reading some annotation that I'm adding to this pod.
It is Visio. I knew it.
Well, it's a visualizer.
It's not true. It's all fake.
It's almost true, except that whoever this service is talking to has a different.
So
right,
you don't really have the right network topology. You have a right list of pods.
Right.
But how they connected to each other, it's actually something that you hard code.
Exactly. So
for the visualizer. Not represents what really happens.
Right. And that is a big issue, right? Because how many people here have this happen to them? You're troubleshooting something, you're trying to fix an issue, and you look at documentation for 4 hours, and somebody tap on your shoulder and say, oh, sorry, I forgot to tell you.
That's not up to date.
It's outdated, right? Exactly. So that's what could happen here, especially more so than important for a microservices application. Documentation might be out of date really quickly.
Yep.
So what you really want is to have a full observability into your running system. So to do that, there are a few tools that you can use. Number one is that if you need to understand your network topology of who is actually making the call, there's a really nice tool called Weave. So Weave Scope is something that you can actually put into your cluster, and then it's going to give you a real topology of the network connections that's actually happening in your cluster. So this is something that you can check and to see that you have something really obvious here. Right?
Now,
so
this is a true thing. This is what really happens.
Yes. So this is what really happens at the network level. We are pretty sure we don't have a network issue.
No,
right?
we don't. Everything,
because everything's connected. We can see who is actually connecting to what. You can even dig in if you want to. Right? You can do some troubleshooting there.
And it actually says here is our deployment of 10 pods. This is our deployment of 2 pods. Very nice.
Yeah. But this is at the network level, right?
Yes.
We know the networking is going through. At least we know we don't have an infrastructure issue. But we need something even more detailed because here obviously
something still doesn't work.
Yeah. So at this very moment, then what we really need is application level trace.
Yes.
Right. So I've done this before again, like back in the SOA days, where we have microservices with XML and SOAP and all that, right? But one of the first things that my manager told me to do was to put a header that has a unique ID.
This is how you trace your request through different microservices.
Exactly. And so today what we can do is it was known as distributed tracing, and we can do something with like Zipkin and Brave, or you can carry the trace ID all the way across to multiple layers of your microservices.
And then you can build like a stack trace of network calls.
Of your requests, actually, L7 requests. So typically you will store, like if you're using Spring and Spring Boot, you can use Spring Cloud Sleuth. And then all the traces will go into something called Zipkin, for example, that can help you store all the traces and visualize it. Another tool is called Jaeger that can also help you to see. But here, of course, we can run Zipkin, we can run all of that, but we have the traces stored in Saturate Trace here. So what we can do is to potentially go and try to find and figure out if everything is kind of going through. So we can, there are many, many requests here. Is somebody trying to DDoS me?
We have 10 pods. We're all good. Don't worry about it.
I need more scale, right? So, wow, check this out. So this is my trace tree of a request that's actually good.
It actually going through all the way.
Yeah.
Yes.
But I think somebody wrote a script to DDoS me, apparently. So there are so many different traces here. Oh, my goodness. Okay. Yeah, we can see some people try to hack it as well. Yeah. Good job.
Any SQL injections? we'll check through it later.
We'll try. Well, yeah. So there are so many traces here. What we need is to find the one that actually has the issue.
Yeah, and that will be 500.
Yeah. So we can go ahead and find the 500 errors. Oh, there are quite a few.
Okay. This is ours.
Yeah. This is probably mine. And check this out. So what we can see here is that clearly this request has a 500 error. We can also see the log associated with this particular request if you want to. And then here we have a hit on the hello world service. And we can dig into here, and we can clearly see hello world has a 404.
It doesn't have a 404. It's there.
Yeah.
You know what this 404 is? No. That's the 404 of the error page that we don't have.
Yeah, that's right. Yeah, that's the 404 on the error page. And then this is the 500 on the error page, right? So
here we go.
Problem solved. So there's the 500, there's the 404.
Problem not solved. We still don't know what's going on.
We still don't know where the null came from. But we at this very moment, we can suspect that something happened in my call, right? We couldn't figure this out any other way except through some kind of distributed tracing to kind of see what happened here. So we know something is wrong here.
So we isolated the place of the problem.
Yeah. So now, but we don't know why. So I guess this is where debugging.
Yeah. So we need debugging. We need debugging, obviously.
Yeah. So. But we need some live traffic to debug it, but we can't do it on a...
You cannot connect, so we spoke about you can connect IntelliJ Debugger to your cluster, but then the problem is you will stack everything because every breakpoint you will stop, it will stop the world until you investigate it.
Right.
But this is a live system. People are using it all over the world.
Right.
So we cannot really stop it.
Well, you can if you step over the code really quickly.
Really quickly. So
very quickly.
So people won't feel that you actually step through.
Yeah, it will be 5-minute latency, right?
Yeah, that's okay.
That's okay. But obviously we don't want to do that. How many people here wish you can just have a debugging capability in production environment so you can really figure out what's happening?
But without actually blocking anything.
Without blocking the world, right? So at Google, we can actually do that.
That's amazing.
What we do is we can actually attach a real debugger, what we call the Stackdriver debugger. It's a little Java agent that we can attach to the process. It doesn't matter who you run it. What we can do is, for example, if you really is in a pinch, I really need to know what is happening.
We need to look at the code.
Yeah, we should be able to do this. So my application has a little Git commit plugin added to it.
It is Spring.
Yeah. So in the Git commit plugin, what we did is to store where my source code is, right? So I know this is on GitHub. I know the revision number. So the debugger tool here actually checks out the code to the right revision automatically. So we're looking at the same code that is running in the production environment. And then we can debug it. Now, there are two ways to debug this application. One that's the most popular is by adding a log message.
System out println? Debugging by system out println, anyone?
Yeah.
Come on, everybody. Come on, people.
Everyone. And
if not today, in your early days.
Imagine how you used to do it, right? You would actually go to the source, you check out the right one, you add the log
system
message.
Out printlns.
Yes,
right?
system out printlns. How do you actually do it?
Oh, there is a great technique. It's called bubble sort. Binary sort logging.
Yeah.
It's when you add a first system out on the top, you add a system out on the bottom, and then one in the middle. And then you check which ones are not hit, and then you add system out printlns in the middle of this section until you hit the line that didn't work.
and then eventually you converge. It's a log end process, right? It's very efficient.
Yeah, log end process, very efficient.
However,
log end restarts
yeah.
of your cluster.
Yeah. However, if you need to do this, you need to add a new log message every single time.
Yes.
You have to redeploy it.
Exactly.
You're lucky if you
saying.
can deploy it into your environment within 5 minutes. Then maybe the issues are still there.
Maybe you have WebSphere and then...
If you're unlucky, you deploy it in 1 hour, 2 hours in a day, then the issue could be gone.
Yeah.
So this is how you can do binary search debugging on
this
the
is
Google
very
Cloud
cool.
platform.
Let's do that. Let's add some system out.
So
and
what
then,
we can do,
but the messages are important.
Yeah.
So the first time you give a number like 1.
Yeah. So
and
we
then,
can do that. Yeah. So let me do that. So what we can do is add a log point. So I'm gonna come here and say add a log, right? So how do you do this? Number 1.
1. Yes. 1.
I'm here.
No, I'm here as the second one.
Oh. So what is
this? This is just 1.
1 starting.
Yeah, that's good. All right.
And then someone in the end, like
you can add something meaningful like yes.
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 It works. It works.
There you go.
Okay, so we got that.
All right.
And then somewhere in the middle.
That will be 1.5.
Let's do that one. All right, so I'm going to say that 1.5, the name is name.
There you go. Awesome.
Yeah. So I can add as many debugging messages I want. And every time I come through this line of code, these these log lines will actually be executed, and it will actually run, and we'll actually see it.
Let's see it.
So let's take a quick look here. So I'm going to do a refresh. And remember how we can go see the logs? We can come back here. We can go to the log console if you want to. So here we go. You have centralized logger. This is all being outputted to Std Out, right? This is one of the easy way to kind of figure out what's going on.
Remember our good login messages? This is where they come into play. You can search for yes, and you will find it.
Yeah, exactly. So yes, like that.
Yeah.
Or search for it works. Or let's try yes first. I don't know if I have anything. Oh, you're absolutely right.
There you go.
Yeah, so here we can clearly see, yes, it works.
Amazing.
Yeah, so if I clear the filter, for example, or if I search for this thing called log point, that's what we will insert into the log. So we can search for that too. So I'm going to say log point. And we should be able to see all the log messages that's
This is
through.
all our log points that we added.
So we can clearly see it works, and we can see like all of these things. But this is not my particular session. So if we really want to, we can limit the log messages to a particular session, for example.
Because so we got now logging from all of them.
Exactly.
From all the production cluster. And most of it works. So this is why we got so many yes, it works.
Exactly. And if you have a session variable in scope, or if you have the request ID in scope, you can put it here, and you can do some kind of expression to kind of figure this out. So I don't know. Let's go back and just double check this again and see if the log messages tell me anything useful. I'm going to play the log so I can see the latest logs, right? So eventually this is going to catch up, and we should just be able to see the log that I want, right? Yeah, there we go.
Oh, here we go.
Yeah, so it's still working for some reason. Oh, there we go. We see somebody's name is 355 and all that. So I think somebody is DDoSing me right now.
No, they're just using the application. Come on, it's that's the feel of popularity, Ray.
Who is actually using the application right now?
Everybody.
Exactly. Right. Somebody is DDoSing. But so this is what we can do too.
I hope they wrote the script in Python or something.
Yeah. So it doesn't run on memory. Yeah. So anyways, what we can also do is actually.
Well, so the login didn't help us, right?
No.
That's the problem.
Right.
The login didn't really help.
So
what's the next step?
We can attach a real debugger now. So we can attach something that can actually see the code stack. We can actually see all the variables when the request comes through.
That's a very good idea.
Yeah. So what we can do is rather than adding a log, we can add a snapshot. And we can take a snapshot of my running stack as the code is going through. So for example, I can add a snapshot here. And if I go back, or if somebody definitely is generating some name.
Auto-generated names and stuff.
So we can see the name that just came through. Somebody putting this into my app, and we can see all of these other things that's happening here.
Yeah,
right?
that's the stack trace of this call.
Right, exactly.
Very cool.
Yeah,
but it won't help us debug.
No, but let me see here if something kind of failed here, right? Because we do output the name. I have a suspicious feeling that maybe this is what we need to do. We need to say log point 1.2. Is that right?
Yeah.
1.2.
Yeah, 1.2.
I'm gonna log every line here.
That's how we do it.
Yeah. So 1.7. I'm here
Very
now,
good,
right?
very good.
Yeah, yeah, exactly. I can't even spell this correctly.
That's good because then now you can search by your misspellings.
Yeah,
very
exactly.
Good, very smart.
Yeah, best practices right here. All right, so now if I come back to my app, somebody DDoSing it. That's so funny. Let me go and find, well, let me find the name first. So the name, maybe there's something about the name that we can figure out.
Let's see what names do we have.
Yeah, there we go. So the name is, right, that's the thing that we're looking for. And if the log actually comes back, we should be able to see all the different name messages here. What we can also do potentially is to, somehow isolate this particular
now you want to.
What's that?
We can change the IP and not tell anyone.
We can change the IP and, yeah. Or somebody can stop DDoSing, so we can actually.
No, they won't do that. No.
Oh, tell you what.
Oh, here we go.
Where? Oh, there we go. Yeah.
Okay.
Okay. Wow.
So we have all the name is.
Yeah. So name is Dennis. We see that. Oh wait.
What's going on?
The name is empty. Maybe that's the thing that would generate the bad request.
Can we check the sources and take a look at it?
Yeah, absolutely. So here we have the greeting service that we need to call. And then here's the actual greeting service.
And so we get an empty name there.
Yeah, so we get the name here.
And it's empty string.
And we put it into the endpoint. And it will be the endpoint, which will be HTTP hello or service, whatever, hello and / nothing.
Nothing.
Yeah, and if we really want to, we can also add a snapshot point here to capture this request. If we're actually setting the conditions, we will be able to see who actually come through. And here we can see the name is actually empty.
Here we go.
Yeah.
So that's the problem.
And we can also validate it if we want to. So for example, if I want to try this service out, what we can do is to start a shell into our Kubernetes cluster. We can actually give it this request a try, right? So for example, if we go back to the trace, if we actually see the 500 arrow, what we can see is to see what request was actually generated. And then we can go back to the cluster and simulate that as well. So that's pretty interesting if we get our internet back somehow. Yeah. So somebody is not only DDoSing my app, but also DDoSing
crashing the Wi-Fi of the conference. Good job, guys.
Yeah.
Really helpful.
Wow.
Really helpful.
Wow. That's amazing. That's amazing. So yeah. No internet.
No internet. Okay. I guess that's kind of our clue.
Oh, there we go.
Oh, here we go.
Yeah. So
we'll
what
keep
we
going.
can do, we can go ahead and if you really want to, we can go into the shell. So we have a shell pod here running, right? So we can come here. We can do the bash, and then we can do a curl if you want to. Like localhost, not localhost, it's a hello or service, 8080. And if I say hello to Ray, that will work.
That will work. And now
if
try
I
the
say hello
empty.
to nothing, and that's my 404.
That's 404.
Okay, so it's a user error.
It's a user error. Amazing. Okay, how do we fix it now?
So if you want to fix it, of course, you would go ahead and change the code and all that. And
or let's just open a new tab. How about that?
What's that?
Let's just open a new tab.
A new tab? Yeah.
Yeah. How about that?
Oh yeah. So
that's a good fix.
Yeah. So
just open a new tab.
What happened is that the thing is actually storing the session. So if I actually have a new session, then
here we go.
Yeah. There
and
you
look
go.
at all the wonderful comments.
My God.
Now we have 3 minutes to read through the comments.
Yeah. Anyways, be nice people.
You don't want to read. Okay.
All right, so let's go back here, and let's go back to the slides a little bit. We only have a few minutes left.
Yeah, so all we need to do is kind of summary and everything. Yep.
Okay, so just remember, in the microservice environment, you don't actually get all the information in your documentation, right? You really need some way to see the real-time observability. To do that, you can see on the network level or the trace level,
loading.
Yeah, exactly. I'm going to go back this way as well. Or you're going to have centralized loggers, so you can see all the logs in one place. You can do search, and somehow you can query it so that you can do some analysis if you want to. But at the end of the day, if you're in a pinch, if something just don't work, then maybe you do need to have a way to debug your application really, really easily. And this is where you can potentially use the Stackdriver debugging to do that for you if you like.
Okay, what else do we have?
Yeah. Okay. So
we saw 3 tools which are built-in in Google Cloud Platform.
Right.
And that will be this, the trace, the login, and the debugger.
Right.
And thank you all. You can find the sources in Ray's GitHub. show notes with all the links to everything, including the GitHub, and more information about Stackdriver are there. And again, the link is the show notes. So it's really only the show notes, basically.
Yep.
And now you are 100% convinced that you should follow Ray on Twitter, and that will be Saturnism. And my Twitter handle is jbaruch. So thank you very much.
Yeah, thank you for your time. I really appreciate it. All right. If you have questions, we'll be outside. Yeah.
Yeah.